Hey guys, in the next several videos we're going to start looking at hypothesis testing and how do we do hypothesis testing, what is it, and yeah, how do we go through and do some hypothesis tests. So let's first think about what is a hypothesis test. Well, a hypothesis test, this is really simply a procedure for testing a claim about a property of a population, right? So that claim, it could look something like, we think that the proportion of the population that believes something is more than 50%. Or we think that the mean is equal to 7. Or we think the standard deviation is equal to 8. And so it might look something like that. Later on, we will talk about, we might even be testing claims about properties of multiple different populations. But for now, let's think about a single population. When we do hypothesis tests, we think about a test statistic, right? And so a test statistic, this is a statistic that is used to make decisions in a hypothesis test. And we find that by converting the sample statistic to a score with the assumption that the null hypothesis is true, right? So here, when we find this, we are making that assumption that the null hypothesis is true. If that null hypothesis is true, then this is a score that would be associated with that. So we have two types of hypotheses that we will look at. So our first type of hypotheses that we will look at is the null hypothesis. The null hypothesis, this is a statement that a population parameter is equal to some value. And so what that might look like is it might look like we think that the proportion is equal to 70%, 0.7. Or maybe it's a statement about the mean. We think the population mean is equal to 32. Or maybe you have something where you're talking about a standard deviation. We think the standard deviation is equal to 1.4. The null hypothesis will always, 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 always be a statement that some value is equal to some other value. So it will always have an equal sign. The alternative hypothesis, then, is a statement that a population parameter is not equal to some value. So there, it is not equal to some value. So this might look like the proportion for the population is not 70%. But that's not the only way it can look. So if something is not equal to a value, we can be very specific on how it's not equal to a value. We could say the mean's not 32 because the mean is actually larger than 32. So we might have an alternative hypothesis that has a greater than sign. Or maybe we would say a standard deviation is not 1.4 in a specific way. It's actually less than 1.4. So any of these three signs, the not equal to sign, the greater than sign, or the less than sign, those could show up in an alternative hypothesis. The null hypothesis will always have an equal sign. The alternative hypothesis could have any one of these three different signs show here. So how do we go about determining a null and alternative or alternate hypothesis? So we'll go through 4 steps. Our first step is we want to write that claim symbolically. So we write the claim in symbols, whatever claim is being made in a particular problem. Next, we write the opposite of the claim symbolically. The symbolic representation without equal, that is your alternative hypothesis, the alternate hypothesis. The claim that does include the equals, we change that to just an equals, and that is your null hypothesis. All right, so let's see this in an example. So here we want to identify the null and alternative hypotheses to the claim. The mean wait time at Chick-fil-A is less than 2 minutes. So the claim that is being made is a claim about the mean, so mu, and the claim is the mean is less than 2 minutes. So mu is less than 2. So we identify the claim, then we identify the opposite. So the opposite of the claim is, no, it's not. It's not less than 2 minutes. So if it's not less than 2 minutes, it is greater than 2 minutes, or it's equal to 2 minutes. So that is the opposite of the claim. So once we have those, we can use those to identify our null and alternative hypothesis. So the alternative hypothesis is the one of the two claims, either the claim or the counterclaim, the opposite of the claim, the one that does not include equals. So the second one, that includes equals, so that is not our alternate hypothesis. This will be our alternate hypothesis. And to identify an alternate hypothesis, we usually use an H with a subscript of an A. So our alternate hypothesis is that mu is less than 2. The mean is smaller than 2. Then the null hypothesis, we can get this from a couple different ways, but we can say we have our alternate hypothesis was that the mean is less than 2. Just change that less than to an equal sign. The null hypothesis, we will use a subscript of an O, like the original hypothesis, the null hypothesis. So we have our null hypothesis is the mean is equal to 2. The alternate is the mean is less than 2. So here, our alternate hypothesis happened to match up with the claim. The null hypothesis didn't match up with either the claim or the opposite of the claim. It was a little bit different than both of them. Remember, the null hypothesis is always, always, always an equal sign right here. So if you have anything other than an equal sign, that's not quite right. All right, we will look at some more of this in our next video.